All right, in this video, we're going to recap solving absolute value inequalities. So if you have your notes packet, you've seen this before and you should have this, but when we are talking about absolute value inequalities, we have two types. If it's less than or equal to or less than, it becomes an and statement. And remember, once we have solved an and statement, we need to have two number lines. We need to have a rough draft and a final draft, and the rough draft is so that we can see where there's an overlap. The other option is that we have greater than or equal to or just greater than. That's going to become an or statement. When we have an or statement, only one condition must be satisfied, which means it doesn't matter if they overlap or not. They could overlap, that's great, but they don't have to overlap. So we're going to look at an example that we did together in class. And this first one, the absolute value bars are already by themselves. Okay, since they're already by themselves, we can figure out if it's an and or an or. So since it's great or, it becomes an or. Okay, so we have two options. The first one, we're going to drop the absolute value bars. Notice how I'm never solving when there's still absolute value bars. I rewrite it without the absolute value bars. Or we have the same thing on the left side, but then we flip the sign and make the right side negative. Okay, so we solve both of those inequalities and we have two statements. X is greater than 2 or x is less than negative 4.5. Since it's an or, we throw them both on the graph. The interval notation is wherever we see at least one line. So we start over here at negative infinity. And we're going all the way until negative 4.5. So we have negative infinity to negative 4.5. We have a parenthesis around negative 4.5 because it's an open circle. And then we have a break in the graph. Since we have a break in the graph, we're just going to put or, and it picks up at 2, and it goes all the way to positive infinity. Okay? And remember, those infinity signs always get parentheses. All right, so moving down, this is an example of when the absolute value bars aren't alone at the beginning of the problem. If they aren't alone at the beginning of the problem, we have to get them alone. So since here the 2 is being multiplied, we had to divide by 2. Okay, that got us absolute value, a half x minus 10, in the absolute value, less than or equal to 4. Now that we have this, we can figure out if it's and or, and then break it up. Since it's less than and, we're going to solve both and then find the overlap. So you can see here, I set it up exactly like it was without the bars. Over here, the left side stayed the same. The sign flips so that the other side can become negative. We solve it, and then we have an and statement. When we have an and statement, we made a rough draft. Okay, our smaller number came first, and then our bigger number. We put them both on the number line, and then we found the overlap. That overlap is what went on the final one. Okay, so the interval notation here, we have nothing, nothing, nothing until 12. 12 has a closed circle, so we're going to put a bracket, and then it goes all the way to 28. Another closed circle, so another bracket. Okay, I want to recap one more. And that's this one right here, because as you can see, we had something after the absolute value bars. So the absolute value bars weren't alone. Okay, we had to get them alone by subtracting 3. Okay, once we subtracted 3, we had an absolute value statement where the bars were alone, so then we could figure out if it was less than or greater. Since it's less than, it's an and statement. Okay, my first one is the exact same statement without the bars. The second one, the left side stays the same as this blue one right up here. And we had to flip the sign and make the right side negative. We solved, we made a rough draft, we figured out where it overlapped, and then we did the interval notation. Okay, I said that was going to be it, but I did want to talk about one more. And these are these special cases. All right, so our special cases are when we have a negative on the right-hand side after we get the bars by themselves. Remember, you could solve these like normal and still get to your solutions, okay? So don't panic if you forget to notice the negative. It's all right. You can still solve this as an or statement But what you'll see when you have your or statement is that there's always going to be a number that works for at least one of them. Okay? So what this is saying is that when we take the absolute value, it's going to be one of two options. It's either going to be 0 or it's going to be positive. Well, no matter what it is, 0 or positive, that's always going to be bigger than negative 16. So any number would work. Down here, after we got the absolute value bars by themselves, when we take the absolute value, it's never, ever going to be less than negative 25, right? A positive or a 0 cannot be less than negative 25. So we add no solution. When we have no solution, we have to leave them blank.